items to start. The webinar will be recorded and available on the LABBC website. All attendees' lines will be muted. You can submit questions using the chat box. And at the end of the webinar, we will do as many Q&A as we can to fit in the time. And as follow-up, we will email the webinar recording with the slides as well as answers to all the questions. Today's panelists include top industry professionals with decades of experience in water efficiency. I am Maureen Arbesnik, and I've been implementing water efficiency programs and projects for the last 30 years, and now act as the Water Technical Advisor for the Better Buildings Challenge. Ben Slick, VP of Business Development for HydroPoint Data Systems, will start the presentation off. HydroPoint is the provider of two of the most innovative water management systems, WeatherTrack, which focuses on reducing waste through efficient irrigation controls, and Water Compass, a solution for flow monitoring and leak detection. As HydroPoint's business development leader, Ben works with Fortune 500 companies, ESCOs, municipalities, and portfolio owners and managers to implement strategies that promote efficient water use, identify leaks and water loss, and just manage overall water use. We also have Danny Gleiberman from the Sloan Valve Company on our webinar today. The Sloan Valve Company has been innovating plumbing fixtures for more than 100 years when they invented the Royal Flush Valve. Sloan has led the plumbing industry in water efficiency, including efficient flushometers, water-free urinals, and hybrid urinals available for retrofits. Danny is the Manager of Product Compliance and Government Affairs for Sloan and is an active leader in the plumbing industry. He's held previous chair posts with the Plumbing Manufacturers International on the Government Affairs Committee and is currently the co-chair of the Water Efficiency and Sustainability Committee. And he's also served as a 3-time board member of the U.S. Green Building Council here in Los Angeles. And finally, we have Terry Waldo, an executive VP at Dynamic Water. Terry has spent over 25 years in the water treatment industry and literally worked in every area of the water treatment industry, including leading engineering and technical teams, as well as service groups. Today, Terry is going to be discussing Dynamic Water's innovative water treatment solution, which uses partial electrolysis to treat water and thereby eliminating the need for chemicals and significantly reducing water use. Quick background on the Better Buildings Challenge. The Better Buildings Challenge is a national leadership initiative and national competition to encourage and recognize cities and companies that commit to reducing their energy and water use. The City of LA and the Mayor, through the Sustainability Plan, joined the National Challenge, committing to enroll 60+ million square feet of buildings, reducing energy use by 20% by 2020 and 30% by 2035. In addition to the energy goals, the Mayor's plan includes water reduction goals, reducing water use 20% by 2017, which we did, and sourcing 50% of all water locally by 2035. These are extremely aggressive goals, and LABBC offers many services to accelerate project implementation and meet these goals, including awards and recognition, case studies, PR support, peer-to-peer learning, best practice sharing, and technology pilots. To learn more about the challenge, you can contact us at info@la-bbc.com, and we can discuss your goals, objectives, and potential partnership tracks. Another way the city set out to meet these goals was by adopting the existing Buildings, Energy, and Water Efficiency Ordinance. The ordinance has 3 components: annual benchmarking of energy and water use through Energy Star Portfolio Manager, and subsequently every 5 years, a performance track to reduce buildings' energy and water use by specific energy by 15% and water by 20%, or conducting energy and water audits and retrocommissioning. And lastly, the third part of the ordinance is public disclosure of each building's compliance. All buildings 20,000 square feet or more are required to comply with the ordinance. The first benchmarking compliance date is December 1st of this year, for buildings 100,000 square feet or more. This has been changed and updated from November 1st, so please note that. Followed by June 1st of 2018 for 50 to 90K buildings, and June of 2019 for 20 to 49K buildings. Note that these are benchmarking compliance dates. The performance components of the ordinance start in January of 2019, regardless of the size of the building. Buildings will need to demonstrate energy and water efficiency or identify a pathway, such as audits and retrocommissioning, to compliance every 5 years. The following chart shows the compliance dates for the performance aspect of the ordinance, and based upon the last digit of your assessor ID, you are required to comply with the energy and water use reduction or do audits and retrocommissioning sometime between 2019 and 2023. These dates are critical for every building and owner and manager to know for all of your buildings. For water compliance, there are 3 paths. Because Energy Star's water scores are not available for most building types for water, so therefore there are 3 paths. A prescriptive path, which is to conduct a water audit and retrocommissioning for your building. The performance path, which is to reduce water use by 20%, or if your building does not have central cooling, you can elect to perform retrofits of either toilets and urinals, shower heads and faucets, or clothes washers. Or the 3rd path is to bring your building up to the local, municipal, and state code. We're hoping that most customers take the performance path and reduce use. For most buildings, this will be the most cost-effective option and just makes the most sense. Saving water reduces your operating costs. Both water and sewer costs are rising well above the consumer price index with no signs of slowing down. And reducing water use will help minimize the effect of these rate increases in the future. Managing your water use also helps you insulate your facility from the effects of future shortages and droughts and local mandates for reduction. Becoming water efficient also demonstrates your commitment to sustainability and stewardship in the environment. In today's webinar, we're going to focus on the top areas of water use in most buildings, which is cooling tower water treatment, plumbing fixtures, and irrigation. In addition, therefore the top opportunities for water use reduction. In addition, we'll highlight leak detection and the value of data in the overall water management. I'll now turn over the presentation to Ben Slick from HydroPoint to discuss just that.
Thank you, Maureen. Good afternoon, everyone. As we've talked about, there is a substantial monetary benefit to monitoring and tracking water use and being more water use efficient. It hits the bottom line as well as being just the right thing to do. HydroPoint is the maker of both WeatherTrack, which is an irrigation control system, and Water Compass, which is a flow monitoring and leak detection system for indoor applications. There are tangible costs to unmanaged water, which include just what you see in terms of building profitability, but there are secondary and unmanaged consequences of water: moldy foundations, pollution runoff, reslurrying hardscape more frequently than a budget requires just because of overwatering. So there are a number of benefits to getting irrigation under control. And in many cases, antiquated timing devices are what are turning sprinklers on and off. And so what is watering the landscape? The benefit of retrofitting an old conventional timer with a smart irrigation control device is that it will eliminate waste by adjusting a schedule automatically when weather changes. And so thereby taking the guesswork out of when a timer should come on and how many minutes it should run. The truly efficient devices in this category are landscape-based, so you can program what kind of things are being watered. And then augmented by that is real-time weather every day, telling the device exactly how much has evaporated from where it's installed. These devices can also be equipped to monitor flow, both at main line and station line levels so that you can eliminate waste from a broken head or a cracked lateral or a continuous leak. What you want to look for in these solutions are things that have been tested and proven by third-party verification test protocols. In addition to an irrigation control system, the benefit of putting a flow sensing device in line with the irrigation main line allows you to monitor the flow of water, learn flow for a main line, learn flow for station lines, and then be able to set thresholds when those lines or main lines are broken. And so it will eliminate the catastrophic event of a mainline break or the continuous leak on a valve or a broken head. And the benefit of this is to help you capture and retain all the savings you generated by putting in a weather-based control in the first place. Some of the more modern control products also offer software that give you the ability to put a budget in place. It could be the last 5 years, as is characterized by the LABBC, and then you can put target budgets in that either represent your 20% target goal, or it could be your landscape irrigation requirement. But in any case, a real key component of this is being able to see in real time how you're doing against your budget and be able to take quick action if your budget is compromised. The products also have a wealth of reports that can help you better understand how you're spending water, both in terms of your nozzling, as well as on what kind of plant material is receiving the amount of water. And you can put costs to this and even get down to having conversations with business owners about, did you know you're spending X on watering your turf? No one comes in contact with that turf other than the guy who mows it. So maybe that's the conversation about a landscape reimage to further reduce water use at that site. And then there are a series of ongoing monitoring tools that will help people ensure that they're getting the most out of their investment. These services can help escalate problems to landscape contractors and or the building site managers, and also give executives at the headquarters level a portfolio view of how they're doing in real time against their savings targets. One of the case studies using our own product, WeatherTrack, is in the California Department of Transportation. District 12, which is all over Orange County, has widely adopted WeatherTrack with over 430 irrigation control systems being retrofit. And the results have been, from the first year of installation, a quick payback and an ongoing level of water use efficiency for them. So a lot of our customers would tell us, we love the WeatherTrack product for outdoor use and we're helping to manage that, but we've got other water applications that are metered and monitored, or unmonitored, I should say. And so what can you do for us? And so we developed a product called Water Compass, which allows you to put a non-intrusive sensor on a water meter and have it record all the use of that meter, and then once a night, batch that up into the cloud where an application called watercompass.net will allow you to see your information on a daily basis. It's like getting a sneak peek at your water bill every day. The Water Compass device is applicable to any really metered application for water, domestic, compound meter, irrigation only. On cooling towers, you can meter makeup and blowdown lines separately and look for evaporation credit. You can monitor water-based fire suppression systems, pools, fountains, splash pads, any number of applications that are, again, water-based. Water Compass allows the user to visually identify usage patterns, and it allows a monitoring team at our office to help them identify trends, use that is considered normal, and then also look for anomalous use, unexpected use, catastrophic changes in use. And these are all drillable, clickable dashboards for the customer. This gives the ability to monitor a single meter, or all the meters at a single site, or all the sites within a portfolio of real estate to drive domestic irrigation or other applications as split out, just helping you better track and manage water well before you actually receive the water bill so you can take action if there's a problem. The tools also give you the ability to heat map time of day and hour of day usage, so you can kind of see where your most high-level usage patterns are, and if those jive with what you'd expect, then great. If not, it's an area for inquiry. Part of the Water Compass product is an automated alert system, but that's also backed up at our headquarters with a team of people that are actually looking at this same water data and then annotating the automated reports, helping you better understand where the problems exist and when they started and what their trend is. And then we work with our customers to help them figure out where those leaks are, to help them fix them, and then we track the results of those fixes to show them the decreased anomalous use. A sample case study is in a very large shopping center where we installed 2 different sites, one on the East Coast, one on the West Coast. We found that we identified over 32 million gallons of water that they couldn't explain where it was going. The pilot results were we started doing audits interior to the water using tenants in the mall. We found a yogurt shop that had a machine that was by design discharging 600 gallons of water an hour into a drain. That added up to a lot of water loss and a lot of water unnecessarily used. And so they would have never known that without this product. So in summary, HydroPoint has worked with the largest real estate companies, big box retailers, municipalities, high-tech companies, Fortune 100, and even sports stadiums to help them identify their water use patterns and drive down use through implementation of both technology and best practices. And I'll yield the rest of my time to our next panelist. Thank you, Maureen.
Thanks, Ben. Danny?
Hello, everybody. Maureen had offered a good overview of the existing building energy and water efficiency ordinance from the city of Los Angeles, and she showed a slide that estimated about 40% of indoor water use in a commercial setting is for sanitary purposes. What I'd like to do this morning very quickly is just kind of review Sloan's commitment to water efficiency, what the plumbing industry has done, share some new innovations that we think are of great value to building owners and portfolio managers that have to comply with the ordinance, and then just show you briefly, as Ben did, a couple of case studies to give you an idea of what kind of options are available to you. Next slide, Mo. Remarkable strides in technology have been made in the plumbing industry. This slide shows you a few of Sloan's offerings, but I would be remiss if I didn't say that the plumbing industry as a whole has taken this concept of water efficiency and really developing and engineering and bringing to the marketplace products that actually can do the same or even a better job with less water. And what we have today, and part of this webinar and the ordinance from the city of Los Angeles, we have a unique opportunity to really look at your building, whether it be a single building subject to the ordinance or a major portfolio, and decide what is right for your building. How do you know what's right for your building? How can we at Sloan and other companies like Sloan help you to achieve what's necessary for your building and meet the water savings, not only as required by the ordinance, but in essence for your life of your building, to make a sustainable kind of building now and in the future. Next slide, Mo. So one of the innovations, and I'll focus a little bit on this because it is innovative in the marketplace, is what Sloan has done with our partner Falcon on a hybrid / water-free urinal. For those of you that have been to places like the Rose Bowl or Dodger Stadium last night during our great victory, you may have seen these water-free urinals and not thought much about them. But in essence, we've provided a new system called a hybrid that, in addition to all the water and cost savings of a non-water urinal, provides a small jet of water, 1 to 2 gallons every 3 days behind the wall to deal with some of the attendant issues of buildup in the drain line. So this is what a retrofit urinal looks like, and you basically hook up to an existing water supply on a retrofit setting, a chrome-plated tube that behind the wall and in the back of the urinal injects a gallon of water every 3 days into the drain line. What that does is a number of things, including maximize water efficiency. It is still a non-water urinal because each use doesn't require any type of flushing. We're not really talking about lead points today, but I'm sure some of us on the webinar are familiar with the accumulation of and the accreditation of LEED projects and green projects, and this is a great product for that. It prevents struvite buildup and drain clogging in the pipes, and it eliminates some attendant maintenance issues that, while are not burdensome and onerous, do cause some problems for some facilities. Next slide, please. This would be if you want to know how it actually works, you can go to Sloan's website. I don't want to take up the time now, but there's a nice cartoon video of how it actually injects water into the drain line. And one of the things that we want to just mention is that in addition to conforming to the ordinance, which is vitally important for all of us on this webinar, Sloan strives to make sustainable products, and we're starting to have declare labels and other types of sustainability transparent documentation for you, so you understand how our products are made, where they're made, and kind of what their life cycle is, which is, again, not necessarily subject of the ordinance itself, but we feel should be important for consideration when you look at what is best for your building. Next, you can go to the next slide. And so just by way, and when we get to the case studies, I'll talk again about water closets and faucets, because remember, one of the slides that Mo showed was that 40% of indoor water use is from sanitary purposes, commercial. But this gives you an idea of what we've done to allow the marketplace to understand how this new innovative technology works, with some high profile locations, and to show you kind of what their experience has been. All of these continue to be in use and great success, and in fact, each one of these facilities has expanded from what we would deem not even pilot programs, but initial trials, to much larger implementations at their facilities. This is some more local ones. You can, I mean, we don't, again, the slide deck's going to be available to everybody. So, Mo, if you want to go to the next slide. One of the things that we did is, not that we're partners with LABBC, but as a new technology or an innovation of an existing technology, we wanted to make sure that people were aware of what we were doing. And we do have a successful installation right at the LABBC headquarters. I want to stop on this slide for just a minute to mention that one of the opportunities that I think it's important for everybody who's participating this morning is aware of is that the ordinance does require certain things of building owners, and we want to do what's right for them, whether it be a hybrid urinal or a non-water urinal or a high efficiency water closet. And right now there are rebates available through LABBC, which Maureen and her group at the LA Better Building Challenge can give you more information on. And I kind of want to tie those two concepts together, because right now the city is, on the one hand, encouraging you to change out fixtures in your facility through rebates, and on the other hand, coming down the line in 2019, which is right around the corner, actually going to be requiring you to do certain things that would lower your water use by 20%. So on the example of just a hybrid or a water-free urinal, right now there's a substantial dollar rebate amount, and if you are replacing anything greater than a 1.0 or even a 1.0 gallon urinal, you're going to save almost 100% of the water usage of that particular fixture in that particular facility. If you go to the next slide, Mo, we have some case studies that show what can happen at a facility on a large scale when they make the commitment to decide which fixtures are the best for them, and they change out those fixtures in a rather large fashion. So for the LA Convention Center, there was a total of 700 toilets changed out and a variety of faucet upgrades and urinal upgrades. And you can see the chart that goes from January of 2016 to January of 2017. And overall, there was over a third of water savings annually. Clearly, this is a large scale project. A lot of considerations went into what types of fixtures they wanted to do and how they wanted to implement it. But if we use this as an example of what might be done in an existing building with change outs, you can see that you can easily achieve the city mandated 20% requirements for your overall water usage from an indoor standpoint. This is another case study, and even though this isn't in the city of Los Angeles, because it was actually the municipality of Culver City over a series of several months, it indicates kind of what kind of water savings are available in different types of facilities. You know, one of the things that will be a challenge that we want people to be aware of as they move forward in compliance with the ordinance is that each facility is different, and a project that has older plumbing may not actually want to go to the highest efficiency water closet, which we make and others make at 1.1, because you're going to be asking that high efficiency water closet to basically do the work on a much older plumbing system that was designed for greater water. So just as an example, different types of facilities would, after the audit and after some work with partners like Sloan and your plumbing designers, engineers, and facility managers, look at what options are best available to you that achieve your water savings given the unique circumstances and characteristics of your existing facilities. There's some additional information about the hybrid urinal. It's, again, as Mo mentioned very nicely in the introduction, Sloan has been doing this for over 100 years, and we're proud to always be innovative and always thinking of ways to help improve our customers' aesthetics, the experience, but also the performance. One of the keys to us is that we want to provide products that maintain the highest water efficiency and reduce water consumption while never sacrificing any type of performance. I mentioned this kind of again at the beginning, and really, I don't believe it's a one-size-fits-all, but I do believe that once you, as a facility manager or a portfolio manager or a business owner or the building owner, start looking at ways to comply, you have available to you a full array of options in the indoor plumbing space with faucets and urinals and water closets. And with that full array, you should be able to look at what's cost effective for you, aesthetically pleasing for you, and ultimately also meets the requirements of the ordinance.
Thanks, Danny. So now, Terry, I'm going to turn it over to you.
Yes, thanks, Mo. Thanks for everybody's time today. We're going to talk a little bit about dynamic water, and we're going to talk a little bit about how we can save water through your cooling tower system. Again, this is a function in the building that a lot of times those of us on this call aren't working around, and so it's critical from a keeping the building cool standpoint. However, it's often not something that's thought about. And when you start talking about, and again, these are just averages because they can go up way higher than this, but through the cooling tower system, the average hospital uses about 20 million gallons. The average high-rise in some areas can use as much as 12 million gallons. And again, they can be much, much higher than this depending on the heat load and the size of the building. Saving 20%, as Maureen mentioned earlier, is an aggressive goal, but also an incredible challenge, but one that needs to be tackled both from a sustainability and a saving money standpoint. And again, in a lot of facilities, depending on the heat load and the quality of the water, the cooling tower is the single biggest user of water, and in this one recirculating system can oftentimes give us the best bang for our buck as far as savings goes. Again, for those of you that don't see them all the time, this is an example of a cooling tower, and essentially water is lost through the cooling tower in two ways. The first way is through the top of the cooling tower, water is evaporated, and this is essentially how your heat load leaves the building. This is the last step in removing heat from the building, therefore keeping the tenants cool. And that water evaporates out the top. And so a lot of times on a cooler day in Southern California, as you're driving around the city, you can see what looks to be fog or plumes that are coming off these cooling towers. That's because that's water that's being evaporated out of it. And so a tremendous amount of water is evaporated out of these systems. The second source of loss is basically through controlled bleed off. And essentially what we need to do is, as the mineral content continues to rise, we have to remove some of the water to be sure that the minerals do not deposit, therefore costing us energy, not letting the systems last as long as they should, etc. So two primary places that water's lost, one through evaporation and one through bleed off. So let's talk a little bit about how much water we're talking about. And so essentially, if we look at a typical 2,000-ton cooling tower operating at 40% load, kind of an average in Southern California as far as a high-rise building or a smaller hospital. And let's say we're running 4 cycles of concentration, and that's very typical of what most chemical water treatment companies are running in the Southern California area. Some lower, some higher, but this will give us perspectives of the ballpark of water we're talking about. In that 2,000-ton cooling tower at 40% load, we're going to evaporate 12.6 million gallons a year. So 12.6 million gallons of water is used from an evaporation standpoint out of that tower to remove the heat load from the building. 4.2 million gallons are going to be lost through controlled bleed off, that we have to get rid of the water to be sure that there isn't some scale issues, which equates to a total of about 16.8 million gallons of makeup water. So a lot of people don't realize that when you talk about the makeup water to a cooling tower, a very high amount of it goes through evaporation. And something that Ben mentioned earlier is a lot of municipalities give credits for the amount of water that's evaporated, because in a lot of places you're paying a separate charge for the sewer fee and the makeup fee. So the water that's evaporated, you shouldn't be charged sewer fees because it doesn't go through the sewer. And if you just use this simple example, 12.6 million gallons of water that's evaporated, if you can work with the city to get credit back for that by using water meters, then let's say an average is $3 per 1,000 gallons on the sewer side, that's $37,000 worth of money right there that you can get back by simply proving to the city that it's evaporating. And so, again, a tremendous amount of water we're talking about. So how do we save water in a cooling tower? Because, as I said, the 12.6 million gallons is a function of the heat load. And so that doesn't change depending on how many cycles you're running. That doesn't change depending on how good we're doing from a water treatment standpoint. That's a function of the heat load of the building. So if we increase from 4 cycles to 10 cycles, which is, again, we typically run 10 to 12 cycles of concentration, the evaporation doesn't change. Still that same 12.6 million gallons. However, we now are only going to have to bleed off 1.4 million gallons. So right there, that change in this 2,000-ton tower operating at 40% load, by going from 4 cycles to 10 cycles, 2.8 million gallons of water is saved just in that one change, which again puts you a long way towards some of these 20% goals. So dynamic water technology, a little bit about us. We are a water treatment service provider. We're focused on environmentally responsible and sustainable water treatment solutions. Again, one of the reasons that the company exists is to do this very thing, to save water, save energy, and do so without the use of chemicals. We are the North American partner of UET, and essentially the system works through partial electrolysis, and I'll talk very briefly about how it works in a second. The technology was developed in Israel by David Scherzer 25 years ago, and it's covered by 9 patents and has over 5,000 plus applications all over the world. Israel and the Middle East obviously has much bigger water conservation and quality issues than we have, and so David saw this opportunity many years ago to be able to save water and energy in that area of the country or in that area of the world, and now that's starting to move across the country, or the world, excuse me. So here's a picture of what the system looks like on the left here. Again, essentially this is reactor-based technology. So what you see here is 16 reactors that we divert water from your recirculating system into and through the reactors and out the bottom. And if you look at the picture on the right, that is a picture inside one of the reactors. And so essentially what happens is you see the rod in the center of the reactor there. That is an anode that creates an electrical current. And so what happens in that reactor constantly as water's flowing through it is we are creating free chlorine in the system itself. And so most chemical treatment programs operate by feeding chlorine from chemicals outside the system and into the system. We are creating it ourselves from electrolysis and the chlorides in the water. And then if you look on the outside of the reactor there, you will see a white precipitate. And so essentially, the way the system allows us to cycle up much higher is we are actually precipitating hardness, calcium, magnesium, silica, the different minerals in the water selectively in the reactor. So we're removing those minerals that are not stable, precipitating them in the reactor, and therefore the heat exchange surfaces stay clean. And on our regular service visits, once we come out monthly at least, but once every 3 months or so, we have to clean that material out of the reactor. So So let's talk about some of the benefits. Obviously, we talked about saving water. We'll talk a little bit about more in a second. Again, generating free chlorine in the reactor to maintain free chlorine at all times. That's a really big game changer when we start talking about biological control and Legionella minimization. The ability to constantly keep a free chlorine residual rather than trying to shock dose it. Real-time monitoring. One of the things Ben mentioned is the ability to track and to detect and have visibility for the things that are going on in a system is a big deal. And we're able to do that through real-time monitoring. Energy savings and improved equipment efficiency. By keeping the system much cleaner, it also drives our energy costs lower. And we'll talk about that briefly. Eliminating hazardous chemicals. In the Southern California area, because water quality is such a big deal, sustainability, saving water, there are properties that have used sulfuric acid or side stream softening for many years to save a little bit more water. Typically, you only get another cycle or two, but essentially at that point, you're introducing a much more hazardous chemical, or from a softener standpoint, you're adding a lot of salt to the system. It's a very high maintenance issue. So we're able to do that without any of these ancillary chemicals. Increasing equipment life is obviously, these are huge investments in your capital equipment, and we want to make them last as long as possible. And cost effectiveness, when you start looking at the operating cost savings, it becomes a very short ROI. So again, briefly talking about water savings, we're able to run much higher cycles of concentration than traditional chemical water treatment. In the Southern California area, we're typically running 10 to 12 cycles of concentration, where most are running 3, 4, 5, depending on the time of year. That savings can be as high as 80% of the overall blowdown and as much as 20% of the overall makeup. And those numbers can vary depending on the quality of the water in your area. And again, we're able to do this without sulfuric acid, without any kind of softening. So let's talk about free chlorine generation real quick. Legionella minimization and biological control is one of the key goals of a complete water treatment program. Water savings is definitely important, but we also need to keep the system clean. And the Cooling Tower Institute, ASHRAE, other organizations recognize running a free chlorine residual at all times is the best strategy for Legionella minimization and control of biologics. The reason most people don't is it just simply is cost ineffective to feed that much product and keep it in there at all the time. And so what happens is traditional chemical programs feed biocide a couple times a week, 2, 3, 4 times a week maybe, feed a high amount, and then let the bacteria start to grow again for a period of time and then shock it again. Again, it's technology that's been going on for many years, but by keeping a constant residual, we keep that secondary growth happening, and we keep those that biofilm down all the time. And again, from a Legionella minimization standpoint, a really big game changer. Real-time monitoring, again, we have a tremendous amount of mechanical equipment that's operating in a cooling tower system. We've got solenoid valves that stick open and closed all the time. That just happens. Blowdown valves. We have makeup water meters that sometimes stick. There's a lot of different things that can happen, and unfortunately, a lot of times it takes somebody walking by the unit to notice that it's occurred, or somebody to happen to be running a test and notice that it's occurred. So we take advantage of real-time monitoring, where our controllers are connected via modem to the cloud. And so we constantly know what's going on with the system. We know what the key parameters are, and we can set alarms so that if something goes out of range, it alerts us. If the conductivity in the system gets low, and it would get low if you're adding too much water because your makeup valve's stuck open, or your solenoid valve stuck open and you're dumping more water than you should, all of a sudden an email comes through to your operations staff, to our service team, says, hey, we've got low conductivity at XYZ Plastics. We pick up the phone, go out there real quick, check to see, sure enough, solenoid valve failed, replaced it, got it done. That happens on a somewhat regular basis at systems all over Southern California and all over the country. The key is, if we find that within an hour, it's no big deal. If we find that 3 or 4 days later after a weekend, all of a sudden we're talking about thousands and thousands of gallons of water that's been wasted. Same thing with free chlorine levels. With a lot of the different parameters, it can alert us when something goes on, and we can trend and graph all that data so that we can start to look at benchmarking of how are we doing and how do we continue to get better. Saving energy and improving efficiency obviously is huge. One of the other largest users of electricity, switching gears to electricity instead of water in your facility, is the chiller system that operates the HVAC. Typically, it is by far the single biggest consumer of electricity. And unfortunately, just a very small amount of deposition, 0.01 inches of scale or biofilm or some combination of any deposit, reduces the energy efficiency of that system by 9%. Again, that can be extremely significant from a dollar standpoint. This drives the cost of electricity off high to keep the building comfortable. And so by keeping constant free chlorine residual and precipitating the unstable minerals in the reactor, we keep those heat transfer surfaces clean and save energy. As we talked, eliminating chemicals, this is a typical picture of what a control room might look like. Again, you've got chemicals there. In this case, we've got sulfuric acid. A lot of times there's secondary containment, sometimes there's not. Unfortunately, within a lot of our spaces, we are actually needing to bring these hazardous chemicals through tenant spaces or through tenant elevators or even through freight elevators. So the liability and the potential for contact continues to go up. And so by eliminating these, we make it much easier so that we can take care of it. Increases equipment life, we talked about that. Essentially, we have a tremendous amount, a lot of times over $1 million worth of capital equipment that we're protecting. And so by keeping the biofilm out, by keeping the heat transfer surfaces clean, by keeping corrosion down, we extend that life on your chillers, on your cooling towers, and on the piping in it. Go ahead, Marie.
Yeah.
Operating expense savings and ROI opportunities. Again, we talked about water savings through increased cycles of concentration, energy savings. Another big thing is maintenance time. If you're like most of the people that I deal with, within the last 3 to 10 years, you're probably getting by with a much less maintenance staff than you used to. And unfortunately, there's just as much work that needs to be done. And so anything we can do to reduce the amount of time that your maintenance and operations staff have to spend taking care of the cooling tower is beneficial. And so things like meeting chemical deliveries, or reducing the number of tests they need to run, or reducing the amount of maintenance that needs to be done to the cooling tower from a cleaning standpoint, allows them to do other things that can have more bang for the buck. Obviously, chemical water treatment cost is eliminated because the chemicals are gone, and increases capital equipment life. So here's just a partial customer list. Again, we're doing a lot of good work in Southern California, some of it through the LABBC and some of it independent of that. But we have a lot of people that are already taking advantage of the water savings, energy savings, and getting rid of the chemicals. And Maureen, I'll turn it back over to you.
Great. Thanks, Terry. Thanks, Ben. Thanks, Danny. Really appreciate you guys sharing all of your knowledge and information on your companies and products. We'll take Q&A here in a bit. I did want to announce, though, before we do that the 4th annual LABBC Innovation Awards is coming up, and we are accepting applications or call for nominations. So if your building has done some great things with energy or water efficiency, or you building that you service or company that you work with, or just any building that you may know about, we are accepting them for Portfolio of the Year, Energy Project, Efficiency Project of the Year, Water Efficiency Project of the Year, and Overall Project of the Year. And here's my contact information if anyone needs to or needs more information or wants to contact us about joining the challenge or water efficiency projects in general.